There is a silence that lives in the high, thin air of the Atacama Desert, a quiet so profound it feels ancient. Here on the Chajnantor Plateau, humanity built a cathedral of listening, a breathtaking technological wonder. The Atacama Large Millimeter, Submillimeter Array, or ALMA, isn't one telescope, but a symphony of 66. They move in a slow, synchronized ballet across the plains, their white dishes turned to the heavens like supplicants. For years they have offered us the universe in a light we cannot see, revealing the cold dust of nascent solar systems and the faint primordial heat from the dawn of time itself. They are our ears attuned to the deepest and most subtle cosmic whispers. On October 12th, those whispers stopped. It did not happen with a bang, but with a flicker on a screen in the operations support facility miles below the array. A single data stream, a torrent of information translating the cold universe into human language, vanished. Then another, and another, and another, an epidemic of silence cascading through the system with terrifying speed. Within 90 seconds, the entire array, our most sophisticated ear on the universe, was mute. Engineers, their faces illuminated by the eerie glow of error messages, spoke in hushed, urgent tones. They searched for the familiar culprits, a localized power surge, a critical server failure, a software glitch. But the diagnostics reported a paradox. The antennas were fine, the power was stable, the network was physically intact. The machinery was alive, yet its soul, its ability to perceive the cosmos, had been surgically excised. It was as if someone had thrown a switch, not in their control room, but somewhere out in the void, plunging them into a sudden and inexplicable sensory deprivation. The feeling in that room was not one of technical frustration. It was a deeper, more primal dread. It was the chilling realization that for the first time in its operational life, ALMA was staring blankly into space, completely and utterly blind. Thousands of miles away, nestled among the volcanic peaks of Mauna Kea, a different kind of eye was also closing. Here, where the atmosphere is so clear and stable that the stars don't twinkle, sit the twin Keck telescopes. They are giants of glass and steel, humanity's sharpest eyes for visible and infrared light, capable of resolving the faint shimmer of a planet orbiting a star trillions of miles away. While ALMA listens to the cold universe, Keck watches the fire. Its astronomers were tracking the delicate atmospheric chemistry of a distant exoplanet, a world we can never visit but can know through the faintest shifts in its parent star's light. Their work is a form of celestial archaeology, decoding the light from the past to understand the present. But as the first panicked emails from Chile began to circulate, the team in Hawaii faced their own crisis. Their adaptive optics systems, the miraculous technology that uses lasers to create artificial stars and cancel out atmospheric distortion, began to fail. The complex web of sensors and deformable mirrors, a system that makes hundreds of adjustments per second, simply froze. The light from their target star, once a crisp point of brilliant data, smeared into an incoherent blur on their screens. Like their colleagues in the Atacama, they ran through every conceivable protocol, every diagnostic, and like their colleagues, they found nothing. No hardware failure, no software bug, no logical explanation. The connection between the telescope and the sky had been severed by an invisible hand. Two of our planet's greatest astronomical assets, separated by the vast expanse of the Pacific Ocean and operating in completely different parts of the electromagnetic spectrum, had fallen silent. This was no longer a localized incident. This was a contagion. The wave of stillness continued its relentless silent creep across the globe. Back in Chile, at a different site in the Atacama, the European Southern Observatories, aptly named Very Large Telescope, also went dark. This facility is not one but four colossal 8-meter telescopes which can work in concert to form a single giant eye on the universe, a technique called interferometry. It possesses the power to see the unseeable, to map the event horizons of black holes and watch stars being born from within their dusty stellar nurseries. Its disconnection was a brutal blow, a blinding of four of our best eyes simultaneously. The reports from the Paranal Observatory were eerily similar to the others. Systems were powered, instruments were healthy, but the fire hose of cosmic data had been clamped shut at the source. The digital nervous system that connected these technological titans to the cosmos had suffered a planet-wide stroke. The pattern was now terrifyingly clear. From the radio waves of ALMA to the visible light of Keck and the VLT, something was systematically disabling our ability to look up. It was a coordinated, creeping blindness, orchestrated with impossible precision. The true scale of the crisis, however, became apparent when the silence leaped off the planet entirely. The call came from the Space Telescope Science Institute in Baltimore, Maryland, the mission control for our most precious orbital observatories. These are the crown jewels of astronomy telescopes flying high above the distorting veil of Earth's atmosphere, granting us a view of the universe that is utterly pristine, a crystal-clear window onto creation itself. Their ground control stations, which serve as the umbilical cord connecting these orbital platforms to their human operators, suddenly lost their primary data links. The telemetry streams the constant flow of health and status. Updates from the spacecraft remained intact. The telescopes were safe, their orbits stable. But the scientific data, the very reason for their existence, the images of glittering nebulae, the spectra of dying stars, the portraits of ancient galaxies, had ceased to arrive. It was an unprecedented event. These orbital platforms are isolated systems hardened against the radiation and vacuum of space. They are not connected to the terrestrial power grids or fiber optic cables that could explain the ground-based failures. Yet they had been struck by the same mysterious affliction. The silence had reached into orbit. It had followed us beyond our own world. This fact alone sent a tremor of profound fear through the global scientific community. The problem wasn't on Earth. The problem was times out there asterisk. But it was the fifth and final report that shattered all conventional understanding and plunged the mystery into the realm of the truly bizarre. It came from the coldest, most remote place on Earth, the South Pole. Buried 1.5 miles beneath the Antarctic ice sheet is a detector of an entirely different kind. IceCube does not look up at the sky. It uses the entire Earth as a filter, looking down through the planet to the cosmos beyond. It is not designed to see light, but to detect the ghostliest and most elusive of all known particles, the neutrino. These cosmic messengers are born in the hearts of stars, in the violent maelstrom of supernovae, and in the mysterious engines of active galactic nuclei. They travel for billions of years in straight lines, passing through entire planets and stars as if they were empty space, carrying unsullied information from the universe's most extreme events. IceCube's network of over 5,000 light sensors, frozen deep within the pristine ice, waits patiently to catch the faint flash of blue light, the telltale sign that a neutrino has finally interacted with an atom of terrestrial matter. It is an observatory fundamentally different from all the others, shielded by a planet's worth of rock and ice from anything happening in our sky. And on October 12th, it too went silent. The data streams from its thousands of photomultiplier tubes, which normally report a steady trickle of particle detections, suddenly flatlined. The background noise of the cosmos, the constant rain of low-energy neutrinos from our own sun and atmosphere disappeared. The universe as seen through this extraordinary neutrino window had gone utterly black. This was the moment the mystery transcended known physics. A cyber attack could not explain this. An atmospheric phenomenon could not explain this. A solar flare powerful enough to disrupt a detector buried under a mile of ice would have simultaneously fried every electrical grid on the planet's surface. But there were no such reports. The world's infrastructure was fine. Only our eyes and ears on the universe had been targeted. What force could possibly connect an optical telescope on a Hawaiian volcano, a radio array in a Chilean desert, a space telescope in orbit, and a neutrino detector at the bottom of the world? What kind of event could simultaneously block photons and neutrinos, particles that barely interact with each other, let alone with the same barrier? The shockwave was instantaneous. In control rooms from Munich to Pasadena, a frantic 24-hour global conference call began. The world's best minds grappled with the unthinkable. The first and most obvious suspect was a hostile act, a cyber attack. It would have to be the most sophisticated and perfectly coordinated digital assault in human history. A ghost in the machine that could infiltrate dozens of unique, highly secure and isolated networks across multiple continents and even in space all at once. The perpetrators would have needed to find and exploit zero-day vulnerabilities in bespoke software systems, a feat so improbable as to border on magic. And for what purpose? To blind astronomers, there was no ransom note, no political statement, just an unnerving, perfect silence. The motive was as invisible as the method, and even this theory, as paranoid as it seemed, could not account for the neutrino silence at IceCube. You cannot hack a particle interaction. You cannot write a code that tells a fundamental force of nature to stop working. The cyber attack theory, the most terrestrial and familiar of the fears, was the first to fall. Natural phenomena were considered next. A massive, unpredicted geomagnetic storm from the sun. But every solar observatory, both on the ground and in space, confirmed the sun was quiet in a period of serene calm. There was no coronal mass ejection, no blast of charged particles that could have wreaked such havoc. The Earth's magnetosphere was undisturbed. Could it be a burst of energy from deeper in space? A gamma-ray burst? These are the most powerful explosions in the universe, the death cries of massive stars. But they are fleeting, lasting only seconds or minutes, and their high-energy radiation would have been detected by other satellites that were still operational. The blackout was not fleeting, it was persistent. It was now entering its 12th hour. Every logical, earthbound, or cosmological explanation was examined, dissected, and ultimately discarded. They all failed to account for the sheer breadth and specificity of the event. It was a phenomenon that targeted only our most advanced observation tools, ignoring everything else. It was a force that could somehow interact with the entire spectrum of light, and even with the most non-interactive of particles. It was a perfectly tailored planetary-scale sensory filter. With all terrestrial and conventional astronomical explanations failing, a few researchers began to dig deeper into the last few fragments of data recorded in the moments, times before times, the silence fell. They were looking for a common thread, a single celestial object, that all 5 of these wildly different observatories might have been interested in, even tangentially. It was a desperate search, a hunt for a ghost in the final seconds of a dying data stream, and they found it. A faint, unassuming designation in the observation logs of all 5 facilities, 3I, Atlas. The I stands for Interstellar, the third such object ever confirmed to have entered our solar system from the vast dark expanse between the stars. Discovered months earlier, it was little more than a curiosity, a faint point of light on a long hyperbolic trajectory that would eventually swing it around our sun and fling it back out into the void, never to return. It was too small, too distant, too inert to warrant any significant attention. It was just another cosmic tourist passing through. But now it was the only suspect left. This silent visitor, a relic from an unknown star system millions of years away, had been coasting through our cosmic neighborhood, and precisely as it reached a key point in its trajectory, a point where it was under the intense scrutiny of our most powerful instruments, those instruments had been struck blind. A coincidence of such staggering improbability that it defied all statistical logic. We were suddenly confronted by a set of questions so profound they felt like they belonged in mythology, not science. Could this interstellar object, this messenger from another star, possess a physics we simply do not understand? Could its passage through our system have generated some kind of field, some unknown form of energy that interferes directly with our methods of observation? Was this blackout an accidental, unforeseen side effect of its mere presence? Or, and this was the question no one dared to speak aloud in those first few hours, was it something else? Was it possible that this event was not an accident at all, that our sudden planetary blindness was a deliberate act orchestrated by the visitor itself? Humanity has spent centuries gazing out into the darkness, listening for any sign that we are not alone. Now, as a messenger from that darkness finally arrives on our doorstep, we find ourselves suddenly and completely blinded, unable to see it, to study it, to understand what it is. The greatest mystery in human history is approaching, and it has arrived with a cloak of perfect, impenetrable silence. The question is no longer just what is 3I, ATLS. The question is why, as it drew near, did it decide to turn out the lights? What does it mean truly to see? Is it merely the act of catching photons with the wet biological lenses of our eyes? For millennia it was. Our vision was a thin, fragile shell, and beyond it lay an impenetrable, silent darkness. But we are a species defined not by our limits but by our relentless refusal to accept them. And so we began to build new eyes of polished glass acres wide, eyes of woven steel listening for the whispers of creation. We forged for ourselves a new kind of consciousness, a planetary network of perception that reached out from the quietest, highest and darkest corners of our world. This was not one instrument, but a global sensorium, a symphony of observation working in perfect unspoken concert. From the bone-dry plains of the Atacama Desert in Chile, a place so alien it serves as a testing ground for Mars rovers, rise the geometric domes of the great optical arrays. These are our cathedrals of light. By night, their cavernous enclosures slide away, revealing mirrors so vast and exquisitely polished that if one were expanded to the size of a continent, its largest imperfection would be no bigger than a ripple on a still lake. Here we do more than just look. We dissect the light of stars that has travelled for millions of years to die on their surfaces. We split it into its constituent rainbows, searching for the telltale chemical fingerprints of distant atmospheres, hunting for the subtle dip in starlight that betrays a world passing in front of its sun. This is a place of profound silence, punctuated only by the near inaudible hum of cryogenic coolers and the whisper of hydraulic systems adjusting 100 tons of steel with the precision of a watchmaker. The air is so thin, so free of moisture and disturbance, that the sky ceases to be a familiar blue veil and becomes what it truly is, a terrifyingly clear window into the infinite. Scientists here don't speak of seeing planets. They speak of confirming candidates, of teasing signals from noise of building photon by painstaking photon, a census of our galactic neighborhood. Their work is a slow, meticulous dance with the cosmos choreographed by the rising and setting of constellations and the unyielding laws of physics. Each night's observation plan is a masterpiece of coordination, handing off targets to other observatories as the Earth rotates, ensuring that the most compelling celestial events never slip unseen into the dawn. It is a continuous 24-hour gaze passed like a baton across continents and oceans. Half a world away, nestled in a collapsed volcanic caldera in Puerto Rico, another kind of eye once stared unblinking at the heavens. Arecibo, not an eye for light but an ear, a colossal dish, 1,000 feet across, woven into the very fabric of the landscape. For decades, it was the planet's most sensitive radio receiver, a gargantuan cup held to the mouth of the cosmos. It didn't see the fiery brilliance of a star. It heard its rhythmic lighthouse-like pulse. It didn't see the elegant spiral of a galaxy. It heard the faint, pervasive hum of the neutral hydrogen gas from which new stars are born. This was the search for a different kind of truth, a truth written in frequencies and wavelengths far beyond the capacity of our biological senses. The data that poured from its receivers was not a picture but a waterfall of numbers, a torrent of signals that computers translated into maps of magnetic fields, charts of pulsar timings so precise they could rival atomic clocks, and most tantalizingly, a monitored silence listening for the one signal that would change everything. The astronomers who worked here were not stargazers in the traditional sense. They were cosmic listeners, detectives sifting through the static of the Big Bang for clues, for patterns, for the faintest whisper of a voice in the cosmic dark. The routine was sacrosanct. The daily calibration, the tracking of a target as it drifted across the narrow field of view, the constant battle against terrestrial interference, the stray radio station, the unshielded microwave oven. It was a constant effort to maintain a bubble of perfect electronic silence in an increasingly noisy world, all to hear the universe speak in its native tongue. And then there are the new senses, the ones we have only just begun to master. In places like Livingston, Louisiana, and Hanford, Washington, we have built machines of almost unimaginable sensitivity. They are our first outposts for a sense we never knew we had the ability to feel the very fabric of space-time. The Laser Interferometer Gravitational Wave Observatory, or LIGO, is not a telescope at all. It is a gravitational gyroscope, a cosmic seismograph. Two impossibly long arms, each stretching for miles, held in a state of near-perfect vacuum. Down these tunnels, a laser is split and bounced between mirrors so perfectly still that their vibrations are measured in fractions of the width of a proton. For years, these instruments felt nothing but the faint tremors of our own world, a passing truck, a distant earthquake, the crash of waves on a far-off shore. The challenge was to subtract the planet from the signal to achieve a level of quiet so profound that the only thing left to feel would be a ripple from the cosmos itself. The team here operates in a state of perpetual vigilance. Their entire world is the stability of that laser, the purity of that vacuum, the integrity of a system designed to detect a distortion in reality smaller than an atomic nucleus across a 4-kilometer stretch. Their routine is a relentless hunt for noise, an endless quest for a deeper, quiet waiting for the moment when the universe would reach out and touch them, not with light, not with radio waves, but with the pure, raw energy of a gravitational shockwave from two black holes tearing each other apart, a billion light-years away. This is humanity's cosmic sense of touch, and it depends on a level of coordinated, continuous operation that makes all other scientific endeavors seem simple by comparison. This entire global network, these optical eyes, these radio ears, these gravitational hands, is more than just a collection of facilities. It is a single interconnected organism. Data flows between them in rivers of pure information. An alert from a gamma-ray burst satellite can have every major telescope on the planet swiveling to a new patch of sky within minutes, each one gathering a different piece of the puzzle. A gravitational wave detection sends a ripple through the astronomical community, a digital fire alarm that calls every eye to look for the flash of light from the cataclysm that caused it. This is the routine. A highly structured, deeply collaborative, planet-spanning enterprise dedicated to a single goal: to leave no corner of the universe unobserved, to let no cosmic secret pass us by. It is the culmination of our species' desire to know the grandest intellectual project we have ever undertaken. It is a dance of incredible complexity and precision, a testament to what we can achieve when we work together to look beyond ourselves. A routine so established, so reliable, so fundamental to modern science that we had come to take it for granted. Like the rising of the sun itself, the first sign of trouble came not with a bang but with a flicker. In the control room of the Atacama Large Millimeter Array high on the Chajnantor Plateau, a young technician named Elena noticed an anomaly. It was 0314 Coordinated Universal Time, a string of error codes cascading down a secondary diagnostic screen. The antenna phase coherence monitor was reporting garbage data. It was strange but not alarming. These are complex machines, finely tuned and pushing the very limits of technology. Glitches happen. She initiated a standard diagnostic, assuming a localized software hang, or perhaps a timing signal error from one of the hydrogen mesa atomic clocks that keep the 66 separate antennas in perfect sync. The diagnostic routine itself failed. A second, more forceful reboot command was sent. The system did not respond. A cold knot began to tighten in her stomach. Across the room, her supervisor, glancing over, saw the look on her face. "Cryocooler on antenna 27 again?" he asked, his voice casual. Elena shook her head slowly. "No," she said, her voice barely a whisper. "It's everything. The whole array just stopped listening to me. The data stream from the correlator, the supercomputing heart of the telescope that combines the signals from all antennas, had flatlined. It was as if the entire array, a $100 million instrument stretching for 16 kilometers across the desert floor, had simply gone deaf. An urgent call went out to the on-site engineering team. Initial theories were mundane: a power grid fluctuation, a critical failure in the central fiber optic trunk line, a catastrophic server crash. But as the engineers began their checks, a deeper, more unnerving reality emerged. The power was stable. The network backbone was intact. The individual antennas were powered on, yet they stood inert, their dishes frozen against the brilliant starfield like an army of steel giants suddenly turned to stone. They were not broken, not in any conventional sense. They were simply unresponsive. A ghost had entered the machine. At 0319 UTC, 5 minutes after the first error, codes flickered in the Atacama. A phone rang in the control room of the Keck Observatory, perched atop the dormant volcano of Mauna Kea in Hawaii. It was an automated alert from the adaptive optics system on Keck 2. The laser guide star, a powerful beam shot into the upper atmosphere to create an artificial reference point, had destabilized. The deformable mirrors, which adjust their shape thousands of times a second to counteract atmospheric turbulence, were spasming, reporting impossible position data before locking up entirely. Within 90 seconds, the entire guidance and tracking system for one of the world's most powerful optical telescopes was offline. The astronomers, in the middle of a delicate observation of a distant quasar, could only watch in stunned disbelief as their crystal-clear image of a galactic core smeared into an unrecognizable blur on their screens. The telescope was blind. Initial diagnostics pointed to a failure in the laser control unit, a piece of hardware known to be temperamental. But as the support staff began to run checks, they found the problem was far deeper. The primary mirror actuators were unresponsive. The dome's rotation controls were frozen. Communication with the instrument payloads had been severed. It wasn't a single component failure. It was a systemic paralysis, a stroke that had crippled the telescope's entire central nervous system. The night's precious, irreplaceable observing time was lost. Frustration and confusion filled the room. These events were thousands of miles apart, separated by the vast expanse of the Pacific Ocean in two of the most secure and technologically advanced scientific facilities on Earth. At this point, no one had any reason to connect them. They were just two separate, devastatingly unlucky, and profoundly expensive technical disasters happening on the same night. The true scale of the nightmare began to dawn at 0322 UTC. An encrypted high-priority alert flashed across the communication network, connecting the world's gravitational wave observatories. The LIGO Hanford site in Washington state had lost its lock. The delicate resonance of the laser within its 4-kilometer arms, a state that must be maintained with impossible precision to detect space-time vibrations, had been broken. This in itself was not unprecedented. A tiny seismic tremor or a hardware glitch could cause it, but what followed was... As the operators tried to re-establish the lock, the system fought them. The laser frequency controls were unstable. The mirror suspension systems designed to isolate the optics from any conceivable terrestrial vibration were reporting chaotic oscillations. It was as if the instrument designed to be the quietest place on Earth was screaming with internal noise. Just as the site director was getting on a call to the lead engineer, a message came in from the Virgo Observatory in Italy. They too had lost their lock. The time of the event was identical down to the millisecond. And then another message from the LIGO Livingston site in Louisiana. The same catastrophic failure at the exact same moment. 3 separate facilities on 2 continents each, a marvel of independent engineering, had all suffered the same fatal system-wide collapse simultaneously. The coincidence was not just improbable, it was impossible. It defied all statistical explanation. It defied logic. This was not a series of independent failures. This was a coordinated attack. The final piece of the terrifying mosaic slotted into place at 0327 UTC. A frantic, garbled message arrived from the control center for the 500-meter aperture spherical telescope, or FAST, in the remote mountains of Guizhou, China. The world's largest single-dish radio telescope, our planet's newest and most powerful ear on the universe, had gone silent. Its 19-beam receiver, a technological marvel hanging high above the vast dish, had ceased transmitting data. The active surface, composed of thousands of individual panels that deformed to focus on different points in the sky, was frozen in place. The entire facility, a symbol of national pride and scientific ambition, was dead in the water. Within the span of just 13 minutes, 5 of humanity's most significant portals to the cosmos, representing our ability to perceive light, radio waves, and the very structure of space-time, had been systematically and surgically blinded. The news spread like a shockwave through the cloistered, tight-knit global community of astronomers and astrophysicists. Secure phone lines and encrypted chat rooms lit up with panicked, disbelieving messages. Chile confirming it was not a local power issue. Hawaii reporting a complete systems paralysis. The gravitational wave teams sharing telemetry that showed a simultaneous anomalous energy signature just before the shutdown. It was a pattern, a terrifyingly precise, globally synchronized pattern. There was no explosion, no warning, just a quiet digital cessation. The flow of information, the constant stream of data from the distant universe that we had fought so hard to capture, had been cut off at its source. The symphony was over. An unnatural silence had fallen. For the first time in the modern age, our planet was deaf and blind to the universe. We were adrift in the cosmic ocean, our windows to the outside sealed shut, with no idea what unseen force had just closed them, or why. The great dance had come to an abrupt, chilling halt, leaving us to stare into a void of our own ignorance, wondering what was out there in the dark now, watching us completely unseen. In the immediate aftermath, the silence was the most terrifying sound. Not the silence of empty rooms, but a profound digital void. It was as if 5 of our planet's most powerful eyes instruments, designed to capture the whispers of creation, had been simultaneously inexplicably struck blind. Panic, in the rarefied air of global science, is a quiet affair. It is not the clang of alarm bells, but the frantic, soundless tapping on keyboards that yield nothing. It is the hushed, urgent phone calls across continents where the world's most brilliant minds share the same 3 words, "We have nothing." The initial response was a masterpiece of controlled chaos, a mobilization of expertise not seen since the hunt for the Higgs boson. This was not yet a cosmic mystery. It was a terrestrial crisis, a complex engineering problem to be dissected and solved. The world's top diagnostic teams, a global consortium of engineers, cybersecurity experts, and astrophysicists, were spun into action. They formed a virtual war room, a flickering constellation of faces on screens, each a specialist in some form of failure. Their first and most logical suspect was the very lifeblood of our world, the electrical grid. An observatory is a ravenous beast consuming megawatts of power to cool its sensitive electronics and move its colossal structures. A power failure seemed the most pedestrian, the most likely culprit. But 5 of them, separated by oceans and continents, the Atacama Large Millimeter Array in Chile, draws its energy from the robust Chilean Sistema Interconectado del Norte Grande, the WM. Keck Observatory, perched atop Mauna Kea in Hawaii, is tethered to the isolated grid of the Big Island. The South African Large Telescope in the Karoo Desert relies on its own grid, a world away from the infrastructure powering the others. The probability of 5 independent, geographically disparate power grids failing in the exact same second was not just low, it was a statistical absurdity, a ghost in the machine of chance. Yet protocol demanded they chase this ghost down. Engineers were dispatched to humming substations in desolate landscapes. They ran diagnostics on massive diesel generators, the last line of defense, which were designed to kick in automatically, seamlessly, in the event of any grid interruption. Reports flooded back into the virtual command center, each one a carbon copy of the last. Power was stable, the lines were clean, the voltage was perfect. The backup systems were armed and ready, their digital hearts beating, waiting for a failure that never came. They hadn't activated for one simple, chilling reason the observatories had never asked them to. It was as if the facilities themselves had simply decided with a unified and inscrutable will to cease drawing power. They hadn't lost their connection to the world, they had severed it. The first suspect was exonerated, and a cold thread of unease began to weave its way through the investigation. With the electrical grid cleared, the collective gaze of the investigators turned inward from the copper wires to the fiber optic cables. They pivoted to the 21st century's most pervasive terror, a global cyber attack. This was a far more plausible and in many ways more frightening scenario. A coordinated malicious piece of code, a digital phantom, could theoretically ripple across the globe in an instant. It could target the highly specific, often bespoke software that acts as the central nervous system for these technological titans. Imagine a silent, invisible predator hunting not with tooth and claw, but with poisoned packets of data designed to infiltrate the most secure networks on the planet. The world's premier cybersecurity agencies were brought into the fold. Teams from the NSA, from GCHQ in the United Kingdom, and from other, more shadowy organizations began a deep dive forensic analysis. They descended into the digital catacombs of the observatory's networks, a world of logs, firewalls, and encrypted data streams. This was a digital ghost hunt on an unprecedented scale. They were searching for a signature, a single line of rogue code, a telltale backdoor left ajar in the billions of lines of software. They scoured the system logs for any unauthorized access, any unusual commands issued in the moments before the shutdown. They deployed sophisticated hunter-killer algorithms to sniff out the faintest scent of malware, a hidden string of instructions that might have commanded the telescopes to go inert. For days, the digital detectives sifted through terabytes of data. They found nothing. No breach, no intrusion. The networks were pristine, hermetically sealed. The firewalls were untouched, silent fortresses that had seen no enemy. The commands that had shut down the telescopes they discovered were not malicious forgeries from the outside. They were authentic, properly authenticated instructions originating from times within times, the core control systems themselves. Even more damning for the cyber attack theory was the physical evidence. It wasn't just software that had failed. In several observatories, critical hardware components had gone offline. Cryocoolers essential for keeping sensitive infrared detectors at temperatures just fractions of a degree above absolute zero had inexplicably entered a safe mode, a process governed by internal hardware logic, not external software. Commands. At one site, a crucial component of the adaptive optics system, a delicate deformable mirror that corrects for atmospheric turbulence, had its power controller board physically burn out. The surge that killed it was localized internal and left a scorch mark that no piece of malware could ever create. A cyber attack is a phantom. It can trick a machine, but it cannot physically reach inside and break it. This was something else. Something that had touched the observatories with a physical, albeit invisible hand. The second and most feared suspect was also cleared. The quiet unease in the command center was now growing, blossoming into a palpable shared anxiety. They were running out of culprits. There remained one great terrestrial suspect, or rather one that bridges the gap between the Earth and the heavens, our own Sunday. An extreme solar flare, a tantrum from our parent star, was a serious and terrifying possibility. We live our lives under a star that is mostly benevolent, but it is capable of unimaginable violence. A sufficiently powerful coronal mass ejection, or CME, a billion-ton cloud of magnetized plasma, could strike the Earth and induce massive electrical currents in our power grids and long-distance communication cables. The nightmare scenario is a repeat of the 1859 Carrington event, a solar storm so powerful it set telegraph offices on fire and created auroras so bright people could read newspapers by their light. A modern Carrington event would be an apocalypse for our technology. It could cripple satellites, collapse power grids, and silence communications on a global scale. The shutdown of 5 observatories would be a mere footnote in a catastrophe of that magnitude. Immediately, every eye turned to our solar sentinels. Satellites, like the Solar Dynamics Observatory and SOHO, stare at the sun, ceaselessly monitoring its every flicker and churn. Their data streams were analyzed with frantic intensity. Scientists scrolled back through the hours and days leading up to the event, searching for the telltale signs of an Earth-directed eruption. They looked for the sudden, brilliant flash of a solar flare, the emergence of a plasma plume from the sun's tortured atmosphere. Again, they found nothing. The sun, in the hours leading up to the Great Silence, was quiet. It was in a period of solar minimum, its surface placid, its mood docile. There were no significant sunspots aimed our way, no CMEs hurled into interplanetary space on a collision course with Earth. Our star was innocent. It was sleeping soundly, and with that final definitive piece of evidence, the investigators found themselves standing at a precipice. They had systematically, meticulously eliminated every logical cause. It wasn't the grid, it wasn't a hacker, it wasn't the Sunday. The rulebook of conventional failure analysis had been exhausted. They were left staring into an abyss of profound impossibility. The problem wasn't terrestrial, and it was in this moment of collective intellectual surrender that the first whispers began to arrive. They came not from the silent, crippled giants, but from the countless other instruments that watch our planet, the unsung heroes of Earth science that monitor its subtle rhythms. These instruments had not gone silent, and they had a story to tell. The first clue emerged from deep within the Earth itself, a global network of magnetometers instruments that constantly measure the strength and direction of our planet's magnetic field had recorded something peculiar. It wasn't a violent storm-like jolt, like the kind a CME would cause. This was something far more subtle, far more insidious. For a period of 90 minutes, peaking at the exact moment the observatories went down, the Earth's magnetic field had trembled. It was a low-frequency perturbation, a deep, resonant hum that vibrated through the planet's protective magnetic shield. Scientists who studied the data described it as if a colossal, invisible tuning fork had been struck somewhere in the solar system, and our entire planet had resonated with a faint, ghostly note. This vibration was too weak to disrupt power grids, but it was profoundly, deeply strange. It was a planetary tremor without a seismic source. Then came a second whisper, this time from the highest reaches of our atmosphere. Data from ionosondes, radars that bounce radio waves off the ionosphere, and from specialized satellite sensors began to paint an equally bizarre picture. At the same time, the magnetic field was humming. Pockets of the upper atmosphere, more than 60 miles up, had become unusually ionized. This wasn't the spectacular widespread ionization that creates the aurora. This was patchy, fleeting, and geographically inconsistent. It was as if a celestial blowtorch invisible to our eyes had briefly and gently seared isolated regions of the sky, exciting the atoms of nitrogen and oxygen into a higher energy state. These phantom auroras, detectable only by the most sensitive instruments, flared into existence for a few minutes and then vanished, leaving no trace but a ghost in the radio data. They obeyed no known patterns of atmospheric or solar physics. They were a blush of energy in the sky with no discernible cause. The evidence was becoming stranger, more ethereal, but it was the third piece of the puzzle that sent a true shockwave of disbelief through the scientific community. It came from the quietest places on Earth, from deep underground laboratories shielded by a mile of solid rock to escape the constant rain of cosmic rays from space. In these subterranean sanctuaries, experiments designed to detect dark matter, or the flicker of ghostly neutrinos, had registered a spike. It was a brief, almost imperceptible surge in background radiation, but this was not ordinary radiation. The particles that had tripped their hypersensitive detectors were unlike anything they had seen before. They were fantastically high energy, possessing a momentum that suggested an origin far beyond our solar system. And they had a bizarre characteristic. They seemed to be highly directional, a tightly focused beam that had pierced the Earth's atmosphere, and a mile of bedrock as if they were nothing. These were not the familiar protons of the solar wind, nor were they the known cosmic rays from distant supernovas. They were something new, something alien, a faint, momentary shower of unknown particles, a message from the void written in a language we did not understand, a magnetic tremor. Ghostly atmospheric glows, a phantom particle shower. Individually, each of these anomalies was a scientific curiosity, a footnote destined for an obscure academic journal. Siloed in their respective fields, the geophysicists, the atmospheric scientists, and the particle physicists had no reason to connect their strange data points. But the investigation into the Great Silence had broken down those walls. In the central virtual command, a new kind of map was being built. Not a map of power grids or fiber optic networks, but a map of anomalous events plotted against time. A young postdoctoral researcher tasked with collating all incoming data was the first to see it. She layered the 3 disparate datasets onto a single timeline. The gentle peak of the magnetic field hum, the fleeting spike of the atmospheric ionization, the brief intense flash of the subterranean particle detectors. And overlaid on top of it all, the precise to the second moment that the 5 great observatories of the world had gone dark. They all lined up perfectly. The graphs were not just correlated, they were identical. They were different manifestations, different echoes of a single unified event. In that moment, a paradigm shattered. The investigation, once firmly rooted in the familiar soil of Earth, was suddenly and violently unmoored. The team had been looking at the problem all wrong. They had been searching for a cause on the inside, assuming one of our own systems had failed us. But the evidence, now undeniable, pointed in only one direction, outwards. The observatories hadn't failed. They hadn't been attacked. They had times reacted, asterisk. They were the canaries in the cosmic coal mine sensitive instruments that had flinched in the face of something that had passed through our planet, something from deep space. Something with enough gravitational or electromagnetic influence to make the Earth's magnetic field hum, to excite its atmosphere, and to shut down our most advanced pieces of technology with what seemed like casual, effortless ease. The unsettling quiet from the mountaintops was not a symptom of failure. It was a warning. The search for a broken switch had ended. A new search, infinitely more profound and terrifying, was about to begin. A search for what was coming. While the world's attention remained fixed on the silent, monolithic dishes pointed uselessly at the heavens, the real story was unfolding far from the spotlight. It wasn't happening in high-level government briefings or emergency sessions at the United Nations. It was happening in a cramped, windowless annex of the Max Planck Institute for Radio Astronomy, a room illuminated only by the glow of monitors and fueled by stale coffee and sheer, unyielding stubbornness. Here, a small, almost forgotten team, the Heliospheric Dynamics Group, was pursuing a path everyone else had abandoned as a fool's errand. They were chasing ghosts in the machine. Their guiding principle was a paradox to understand why the world's most advanced eyes had gone blind. You couldn't look at them. You had to look at everything else. Every other investigation had focused on finding a cause, a singular, powerful event that could knock out 5 technological titans at once. They searched for the thunderclap, the seismic shock, the grand cosmic explosion. But the heliospheric team, led by the brilliantly unconventional Dr. Aris Thorne, was listening for a whisper. They hypothesized that the event wasn't an explosion but an intrusion, a subtle ripple that had propagated through the Earth's interconnected systems. So they turned their backs on the offline giants and began an exhaustive, mind-numbing deep dive into the archives of instruments that had remained operational during the blackout. They pulled raw data from the global magnetometer network, the very sensors that track the minute-by-minute fluctuations of our planet's magnetic shield. They requested unprocessed signal logs from low-frequency radio arrays in the Australian outback and the high deserts of Chile places, designed to listen for the faint hum of the primordial universe. They even subpoenaed the uncorrected timing data from the entire constellation of GPS satellites, looking for deviations measured in nanoseconds, discrepancies so tiny they were usually dismissed as clock jitter or atmospheric noise. They were data archaeologists sifting through a digital mountain of what most engineers considered junk. For weeks, the work was a grueling, soul-crushing exercise in futility. Their algorithms, designed to find correlations between these disparate datasets, churned through petabytes of information, returning nothing but static. The symphony of Earth's normal activity, the constant fizz of solar wind, the crackle of distant lightning, the deep drone of the planetary magnetic field, was all-consuming. Finding a single anomalous note in that cosmic orchestra seemed impossible. The pressure mounted. Funding committees were skeptical. Colleagues were dismissive. Thorne's team was burning through resources on what looked like a statistical wild goose chase. The silence from the great observatories was a deafening reminder of their failure, a global monument to a mystery that refused to be solved. They were on the verge of admitting defeat, of conceding that the answer was simply not in the data. And then it happened. A junior analyst named Lena Petrova, on her third straight 24-hour shift, noticed it. It wasn't a spike or a surge. It was an absence, a pattern of suppression. On a graph displaying magnetometer readings from a station in Antarctica, she saw a tiny, almost imperceptible dip in the background, magnetic noise lasting for just under 7 minutes. On its own, it was meaningless, a common instrumental glitch. But Petrova had a hunch. Driven by a mix of exhaustion and inspiration, she cross-referenced the exact timestamp of that dip with the GPS timing data. There, buried in the noise, was a corresponding anomaly. A handful of satellites passing over the South Pole had experienced a timing correction a few nanoseconds larger than predicted. It was a phantom, a whisper so faint it was barely distinguishable from the background hiss of the universe. This was the thread. The team frantically began pulling on it. They expanded their search, no longer looking for a loud bang, but for this specific ghostly signature, a brief suppression of ambient electromagnetic energy, followed by a subtle, cascading time-space distortion. And suddenly they found it everywhere. A magnetometer in Brazil, a radio array in South Africa, a research buoy in the Pacific. All showed the same ethereal imprint, the same quiet passage of an unseen force. Each detection was separated by minutes, creating a clear and terrifying sequence. It was a trail of breadcrumbs left by a phantom, Something had moved through the near-Earth environment, not with a roar, but with a chilling, almost supernatural stealth. Using the timing delays between each detection, they performed a kind of celestial triangulation, a technique more common in seismology than in astrophysics. The data points began to converge, not on a location on Earth's surface, nor on the Sun, but on a trajectory, an entry point, a path arcing through the solar system. Their software began to build a model, sketching the Phantom's orbit in three-dimensional space. The result that appeared on the main screen was shocking. The object had come in fast, extraordinarily fast, on a hyperbolic trajectory, the unmistakable path of a traveler from beyond our solar system. It was moving at over 150 kilometers per second relative to the Earth, a speed that no object born of our Sun could ever achieve. It had approached from below the ecliptic plane, a blind spot for many sky surveys using the Sun's glare as a shield. The model showed it executing a gravitational hairpin turn, a high-speed flyby that brought it screaming past our planet at a disturbingly close range. According to their calculations, the point of closest approach was a mere 60,000 kilometers. This was no distant comet. This was a razor-thin cosmic near-miss, an encounter that had happened inside the orbit of our own geostationary satellites. An interstellar bullet had just grazed our world. A frantic search of astronomical catalogues began. Was it a known object? Had someone seen this coming? The major databases of asteroids and comets came up empty. Nothing matched the speed, the trajectory, the timing. It was as if a ghost had materialized in our backyard and then vanished without a trace. The atmosphere in the room grew thick with a mixture of exhilaration and dread. They had found the event, the encounter that had to be the cause. But they had no suspect. It was Petrova again who broke the impasse. She remembered the obscure catalogues, the registries of objects so strange or fleeting they barely registered in the mainstream. She started digging through the archives of the International Astronomical Union's Minor Planet Center, specifically looking for interstellar designations. And there it was, a single lonely entry, 3I, Atlas, the I for interstellar. It had been spotted months earlier by the Atlas Sky Survey in Hawaii, a faint, fast-moving smudge. It was quickly classified, its trajectory plotted, and then for the most part dismissed. The initial analysis had suggested it was a small inert object, perhaps a rogue asteroid or a burnt-out cometary nucleus a few hundred meters across. Its projected path was calculated to pass harmlessly by Earth at what was then thought to be a safe distance. No one gave it a second thought. It was just another piece of interstellar flotsam, a curious footnote in the celestial ledger. But the early observations had been sparse. The object was faint, and its extreme velocity made tracking it difficult. Small uncertainties in those first few measurements, when projected forward over millions of kilometers, could result in massive deviations. Thorne's team realized with dawning horror that the official orbit was wrong. Their data, the ghost signal captured by magnetometers and GPS satellites, was providing a real-time track of the object's actual path. It hadn't passed at a safe distance. It had threaded the needle between Earth and the Moon. They reran their simulation this time, plugging in the identity of 3I, Atlas. The model snapped into perfect, terrifying focus. The trajectory of the interstellar object sliced directly through the positions of the 5 offline observatories. Not near them, through them, as 3I, Atlas, streaked past Earth. Its path across our sky painted a line that connected the Atacama Desert in Chile, the Canary Islands, South Africa, Hawaii, and Australia. The blackout wasn't random. It was a targeted strike path executed by a silent, high-velocity intruder. They had their culprit. They had their smoking gun. But this only opened the door to a far more profound and disturbing question. How? How could a simple rock, even one from another star, disable hardened shielded electronics from 60,000 kilometers away? An asteroid doesn't emit an EMP. A dead comet doesn't project a particle beam. The impact of its gravity alone would be negligible. The established laws of physics seem to offer no explanation. This is where Dr. Thorne's specialized expertise in heliospheric dynamics became the key that unlocked the final chamber of the mystery. He proposed a radical, untested theory. 3I, Atlas, was not a simple rock. Its composition had to be utterly alien to our solar system. He theorized that the object possessed an intrinsic, powerful magnetic field of its own, far stronger than any asteroid or comet ever measured. Or perhaps more plausibly, it wasn't inert at all. It could be actively venting material, not the simple water, ice, and dust of a familiar comet, but a unique exotic plasma, a super-ionized gas composed of elements forged in the heart of a star system, profoundly different from our own, a star system with a chemistry we have yet to imagine. As this interstellar interloper, traveling at incredible speed, plunged through the outer layers of Earth's magnetosphere, it didn't just pass through, it reacted. Imagine our planet's magnetic shield not as a solid wall, but as a vast, complex and delicately balanced structure of magnetic field lines and trapped particles. It's a bubble, our planetary life support system against the harsh solar wind. Now imagine 3I, Atlas, as a hypervelocity needle made of some unknown reactive material. As it pierced the outer boundary of this bubble, it didn't just create a hole. The interaction between its exotic vented plasma and our own magnetic field lines created a form of cosmic friction on an unimaginable scale. It was a celestial blowtorch meeting an invisible shield. This violent, localized interaction generated a focused, coherent channel of energized particles, a temporary conduit that funneled raw energy from the solar wind and the object's own kinetic velocity directly down into the upper atmosphere. It wasn't a broadcast like an EMP from a bomb that expands in all directions. It was a beam, a tightly focused, pencil-thin stream of electromagnetic chaos. And because 3I, Atlas, was moving so incredibly fast, this beam didn't linger. It swept across the face of the Earth like a searchlight, its footprint on the ground moving at hundreds of kilometers per second. The 7-minute duration of the magnetic suppression that Petrova had found was the exact time it took for this energetic beam to slice across the planet's diameter. It was a fleeting, planetary-scale scarification. The observatories weren't collateral damage. They were simply the unfortunate structures standing in the precise path of this sweeping beam. The focused stream of particles and extreme low-frequency radiation was more than their sensitive electronics could handle. It wasn't a destructive blast. It was an overwhelming flood of information, an electronic drowning. The circuits were saturated, the delicate sensors overloaded by a signal they were never designed to see, forcing emergency shutdowns across their entire systems. The mystery was solved. There was no conspiracy, no secret weapon, no solar cataclysm. The culprit was a silent traveler from another star, an object dismissed as insignificant, that had carried within it a chemical or physical property completely alien to our experience. It had brushed past us, and in doing so, had inadvertently fired a warning shot. The findings were presented in a hastily arranged teleconference to a stunned global assembly of scientists and security officials. Disbelief quickly gave way to a chilling realization. We had been visited by something that did not play by our rules, something that demonstrated a form of physics we barely understood. The blackout, the global panic, the weeks of confusion, it was all the result of a chance encounter, a cosmic sideswipe. We now understood what had happened. We knew the name of the ghost that had haunted our planet for those terrifying days. But as the world exhaled in relief, a new, far more profound disquiet began to settle in the minds of Aris Thorne and his team. They had answered the why of the blackout, yet in doing so they had stumbled upon an infinitely greater and more urgent question. The object 3I, Atlas, was now receding, accelerating away from us, back into the interstellar darkness from which it came. We had only the briefest of windows to study it. The most important astronomical discovery in human history wasn't a planet or a galaxy. It was a messenger that had just flown past our door and we had almost completely missed it. What was it made of? Why did it behave in a way that defied our understanding of the universe? And the most terrifying question of all, a question that now hung in the silence of every laboratory and mission control center on Earth, was it natural? To name the ghost is not to understand it. Across the globe, in hushed video conferences and on frantic email chains, the identification of 3I, Atlas, was less a solution and more the beginning of a profound and terrifying new mystery. The question was no longer times what times had silenced our greatest eyes on the universe, but times how asterisk. How could a solitary object, a silent traveler, moving through the void millions of kilometers away, reach across that impossible distance and surgically disable 5 of the most technologically advanced facilities ever constructed by humankind? It was a crime scene without a weapon, an effect without a plausible cause. The laws of physics as we understood them seemed to preclude such a delicate long-range attack. Something was fundamentally wrong with our picture of the cosmos, and 3I, Atlas, was the anomaly that threatened to tear the entire canvas. The initial and most obvious suspect was a burst of electromagnetic energy. This was the brute force method, the cosmic sledgehammer. Investigators first theorized that 3I, Atlas, as it interacted with the charged particles of the solar wind, might have unleashed a directed electromagnetic pulse, a focused beam of radio waves or gamma rays. Such an event, a celestial flashbulb popping in the darkness, could certainly overwhelm sensitive electronics. The complex CCDs in the telescope cameras, the atomic clocks used for timing the cryogenic cooling systems, all rely on exquisitely precise voltages and currents. A powerful enough EM pulse could induce catastrophic surges, frying circuits, and triggering emergency shutdowns in a cascading wave of electronic chaos. It was a clean, simple, and comfortably familiar explanation. For a few frantic hours, it was the theory that allowed everyone to breathe. Teams scrambled, poring over data from magnetometers and radio receivers that had been active during the Great Silence. They were looking for the telltale spike, the electromagnetic signature of the assault. But the data, when it came back, offered no comfort. It offered only confusion. There was no colossal energy spike. While some instruments registered faint, anomalous flickers, they were nowhere near the intensity required to cause such widespread and specific damage. An EMP powerful enough to reach from the object's position and disable the Atacama Large Millimeter Array in Chile would have been a cataclysmic blast visible to every radio observatory on the planet. It would have saturated satellite sensors and potentially even caused visible effects in the upper atmosphere. It would have been the opposite of subtle. Furthermore, the damage profile made no sense. An electromagnetic pulse is indiscriminate, a wave of energy that washes over everything. It should have affected the observatory's robust power grids, their communication antennas, and their support vehicles just as easily as their delicate scientific instruments. Yet, that hadn't happened. The lights stayed on, the internet connections remained stable. The damage was not a sledgehammer blow, it was a surgeon's incision. Only the most hypersensitive quantum-level components at the very heart of the observatories had failed. It was as if someone had found a way to whisper a single destructive word directly into the ear of each facility, and that whisper was perfectly tuned to break only the most fragile things. The electromagnetic pulse theory, elegant and simple, was quietly abandoned. It was the first of many established ideas to fall. With the most conventional explanation debunked the investigation, veered into far more exotic territory. If it wasn't a wave of light, perhaps it was a stream of matter. The new theory posited that 3I, Atlas, wasn't just a passive rock, but an active source expelling a burst of previously unknown high-energy particles. We are constantly bathed in a shower of particles from space, the solar wind, cosmic rays from distant supernovae, but we have built our world to withstand them. The Earth's magnetic field, our magnetosphere, acts as a planetary shield deflecting the vast majority of this cosmic radiation. The particles that do get through are well understood and their effects are accounted for. For 3I, Atlas to be the culprit, it must have unleashed something new, something that didn't play by the established rules. Scientists began to model the possibility of a particle that was both highly energetic and weakly interacting. This was the terrifying combination. Highly energetic meant it carried enough punch to disrupt a quantum circuit upon impact. Weakly interacting meant it could ignore the Earth's magnetic shield entirely, passing through it as if it were glass. It would sail through kilometers of rock and air without slowing an invisible, ghostly projectile. The image that formed was deeply unsettling. 3I, Atlas, in a moment of unknown cosmic alchemy, had acted like a particle accelerator, firing a narrow, collimated beam of these hypothetical particles directly at Earth. It wouldn't have been a wide spray, but a focused shotgun blast moving at near the speed of light. As this ghostly salvo passed through our planet, the vast majority of particles would continue on their way, exiting the other side without leaving a trace. But a tiny, statistically predictable fraction would inevitably strike something, and in 5 specific locations on Earth, those particles happened to strike the most sensitive, most delicate, most finely tuned pieces of matter on the planet, the quantum state sensors and superconducting junctions at the heart of our great observatories. It was a chillingly precise explanation for the surgical nature of the damage. A single one of these phantom particles striking a qubit in a quantum computer or a Josephson junction in a radio telescope's amplifier would be enough. The impact would cascade through the system in microseconds, creating a data error so profound that the facility's own safety protocols would mistake it for a critical hardware failure, triggering an immediate hard shutdown. This ghost particle hypothesis gained traction as researchers from other fields began to find corroborating evidence. Teams managing deep underground neutrino detectors and dark matter experiments facilities designed specifically to look for weakly interacting particles combed through their archives. They found it. At the exact moment of the observatory shutdowns, several of these shielded labs had recorded a burst of anomalous events. At the time, they had been dismissed as instrumental noise, as statistical flukes. But when plotted against the timeline of the Great Silence, the correlation was unmistakable. It was a faint echo of the weapon, a handful of stray projectiles caught in nets a mile beneath the Earth's surface. The theory was compelling. It fit the evidence, but it also opened a chasm of new and terrifying questions. What physical process could allow a cometary body, a mere fragment of ice and rock, to generate and focus a beam of exotic matter with such incredible energy? The power required to accelerate these particles would be astronomical, far beyond anything a natural object should be capable of producing. It hinted at physics we did not yet possess, at forces that had no place in our models of the solar system. The ghost particle theory explained the times, but it painted a picture of a universe far more dangerous and strange than we had ever imagined. Yet even this disquieting theory was about to be supplanted by another one so bizarre, so contrary to our everyday experience, that it bordered on the philosophical. A small radical faction of theoretical physicists proposed a third possibility. The shutdown, they argued, was not caused by anything 3I. Atlas had times emitted, times not a wave, not a particle. It was caused by what 3I Atlas times was asterisk. Their hypothesis was that the interstellar object was not composed of ordinary matter. They suggested it was something far denser, far more exotic. Perhaps a fragment of a neutron star impossibly compressed, or perhaps a shard of what is known as strange matter, a hypothetical substance where quarks are not confined within protons and neutrons. If this were true, 3I Atlas would not be just a rock, it would be a tiny, powerful gravitational anomaly. It would be a rogue mass, a cosmic cannonball warping the very fabric of space-time around it as it moved. We are used to thinking of gravity as the gentle, persistent force that holds us to the Earth and keeps the planets in their orbits. We have even detected the faint, fading echoes of colossal gravitational waves, ripples in space-time created by the collision of black holes a billion light-years away. But those are like the deep, slow swells of a distant storm on the cosmic ocean. The theory surrounding 3I, Atlas, proposed something entirely different. Not a gentle swell, but a sharp, high-frequency vibration. As this incredibly dense object tumbled through space, its immense gravity, concentrated in a small volume, would not just bend space-time, it would make it time's tremor asterisk. It would be a gravitational gyroscope, spinning and vibrating, sending out a continuous, incredibly subtle, high-frequency gravitational wave. This wave would be a shiver in reality itself, propagating outwards at the speed of light. It would not shake the ground. It would not rattle the windows. You would not feel it. Your body, your house, the very mountains are far too crude, too massive to register such a delicate disturbance. To almost every piece of matter on Earth, this tremor would be utterly inconsequential, passing through without notice. but not to everything. Not to the mirrors of the Very Large Telescope, polished to an atomic smoothness and held in place by actuators that compensate for microscopic shifts. Not to the receivers of ALMA, whose synchronization depends on timing accurate to a trillionth of a second. These instruments are not built on the scale of human experience. They are built on the scale of the wavelength of light. They are designed to be so stable, so perfectly isolated from the noisy vibrations of our world, that a tremor in the fabric of spacetime itself would be like a seismic event. The high-frequency gravitational wave from 3I, Atlas, would have subtly, almost imperceptibly, altered the physical distance between two mirrors, or changed the rate at which time flowed for a femtosecond. For the observatory's diagnostic systems, such a violation of the laws of physics, as they should operate within the instrument's protected environment, would be an undeniable sign of total system failure. The fail-safes would engage instantly. The shutdowns would be immediate. It was the ultimate stealth weapon, an attack that used the fundamental structure of the universe as its medium. This idea at first seemed like science fiction. But then the data came in from the gravitational wave observatories LIGO and Virgo. Their primary mission is to look for the low-frequency waves from colliding black holes and neutron stars. To do so, they filter out all other frequencies, dismissing them as terrestrial noise. On a hunch driven by the new theory, analysts went back to the raw data from the time of the shutdown. They removed the filters. They stopped looking for the slow rumble of distant mergers and instead searched for a high-frequency hiss. And there it was, a faint but statistically significant signal, a persistent high-frequency vibration precisely correlated with the object's proximity to Earth that peaked at the exact moment the observatories went dark. It was the sound of space-time shivering. The evidence was overwhelming. 3I, Atlas, was not a cosmic gun. It was a cosmic tuning fork, and its vibrations had resonated with the most sensitive instruments we had ever built, shaking them into silence. This discovery changed everything. It was a paradigm shift in our understanding of cosmic threats, one that filled the scientific community with a new and profound sense of dread. For decades, our concept of planetary defense has been built around a simple idea: finding rocks before they hit us. We have built telescopes and radar arrays to scan the skies, searching for asteroids and comets on collision courses. We have designed missions to nudge them out of the way. It is a problem of kinetics, of celestial mechanics. But 3I, Atlas, revealed a threat we had never even conceived of. The danger was not impact. The danger was proximity. An object like this would not need to hit us to cripple our global infrastructure. A close flyby could be enough. It could pass by silently and visibly, and its gravitational vibrations could potentially disable our communication satellites, desynchronize the GPS network that underpins modern finance and logistics, or even interfere with the control systems of our power grids. We had built a planetary shield against cannonballs, only to discover that the universe could also throw invisible shockwaves against which we had absolutely no defense. Suddenly, the trajectory of 3I, Atlas, was no longer a matter of simple orbital mechanics. It was a forensic clue to its origin. When astronomers reran their models incorporating the object's unbelievable density, its path through our solar system appeared terrifyingly precise. It was not a random wanderer. The gravitational assists it had received from Jupiter and the Sun seemed to guide it with an unnerving accuracy. This forced a radical re-evaluation. Was its path simply a 1 in a trillion cosmic coincidence? Or was it a clue that 3I, Atlas, was not just a natural fragment but something more, something engineered, or perhaps a gravitational captive slung into our system by an unseen, even larger parent body lurking in the darkness of the Oort cloud? The number of alarming possibilities was multiplying. Our planet, which we had long considered an isolated island in a vast empty ocean, suddenly felt terribly exposed. We had seen the weapon. We had analysed its devastating subtle effect. But the new, all-consuming question that eclipsed all others was this: who or what had pulled the trigger? The focus of the global scientific effort shifted once more. It was no longer enough to understand how the shutdowns happened. We now had to understand the object itself. We had to look beyond its effects and stare directly at the agent of our sudden, terrifying enlightenment. We had to know what 3i, Atlas, truly was. Across the globe, a profound and terrifying silence had fallen. Not the silence of peace, but the hollow quiet of a world that had lost its grandest sense of sight. The great eyes we had built to pierce the veil of creation, our technological totems perched on sacred mountains and launched into the void, were now blind. For the teams of engineers and astronomers huddled in control rooms from the Atacama to Hawaii, the initial shock had curdled into a cold, grim resolve. The passage of 3i, Atlas, had not just been a scientific curiosity. It had been an assault, an encounter with a force so alien it had literally broken our instruments of perception. The phantom had swept through our home, and in its wake our connection to the cosmos was severed. The race to see again was on. This was not a matter of simply flipping a circuit breaker. The damage was insidious, a bizarre hybrid of the physical and the digital, as if the object had sung a resonant frequency that shattered both glass and ghosts in the machine. In the high, thin air of the Chilean Andes, Alma's engineers, breathing from oxygen canisters, worked in the biting cold. They discovered microscopic pitting on the surfaces of their 66 radio antennas, a fine spray of cosmic shrapnel that defied analysis. Yet the true devastation lay deeper within the labyrinthine pathways of the correlator, the supercomputer that serves as the observatory's collective brain. Here, the torrent of exotic particles from Atlas hadn't just caused shorts, it had fundamentally rewritten pathways in the silicon, leaving behind corrupted logic gates that behaved like nothing any computer scientist had ever witnessed. It was like trying to repair a human brain that had been taught a new, incomprehensible language against its will. Thousands of miles away on the summit of Mauna Kea, the teams at Keck faced a similar phantom. Their primary mirrors, each a mosaic of 36 hexagonal segments, were physically intact, but the intricate network of sensors and actuators that aligns them with nanometer precision, the very soul of the telescope's adaptive optics system, was in chaos. It was reporting positional data that was physically impossible, as if the mirrors were in multiple places at once. The system wasn't just broken, it was haunted, echoing the bizarre quantum-like state of the intruder that had paralyzed it. The software designed to correct for the gentle shimmer of Earth's atmosphere had no protocol for an object that seemed to warp the very fabric of space-time around it. They were fighting a ghost whose fingerprints were left on every line of code, every diagnostic report. The global response was a testament to a species refusing to be cast back into the dark. Video conferences became a constant, sleepless marathon linking teams across every time zone. A physicist in Germany specializing in quantum chromodynamics found a parallel between the energy signature of Atlas and the decay of theoretical exotic quarks. This wild, desperate hypothesis was instantly shared with a software engineer in California who began writing a new kind of digital filter, a quantum sieve designed not to block the anomalous energy, but to recognize its signature and reroute it, to neutralize its corrupting influence before it could reach the core processors. It was an audacious gambit, an attempt to build a digital immune system against a pathogen the likes of which science had never conceived. Simultaneously, materials scientists at labs in Japan and Switzerland worked feverishly, developing new shielding. They weren't designing simple lead plates, but layered composites of metamaterials, honeycombs of tungsten infused with synthetic diamond and bismuth, engineered to dampen the specific high-frequency gravitational and electromagnetic radiation that had crippled the observatories. C-130 transport planes were chartered by frantic governments flying huge custom-milled plates to remote airstrips in the Andes and on Pacific islands. This was humanity's emergency armor, forged in the fires of crisis, a desperate attempt to retrofit our windows on the universe so they could withstand the gaze of whatever lurked outside. The silent giants were being prepared for a new kind of cosmic weather, a storm that no one had ever predicted. The first true test came once again in Chile. At the Paranal Observatory, home to the Very Large Telescope, engineers began the painstaking process of rebooting Unit Telescope 1 and 2. They had installed the new physical shielding around its most sensitive electronics and uploaded the beta version of the quantum sieve software. You could feel the tension in the control room, a palpable force thicker than the thin mountain air. The command was sent. For a long, agonizing minute, nothing happened. The diagnostic screen remained a flat dead line. Then a single green light flickered. Then another. System after system began to report back their status, changing from a terrifying red UN known to a hesitant amber standby. The team watched, barely breathing, as the first calibration sequence initiated. The massive 8-meter mirror, which had been locked in place for days, began to move. Its gentle, almost imperceptible turn was met with a wave of hushed gasps and tear-filled eyes. Antu was stirring. They pointed it not at a distant galaxy, but at a familiar stable star, Canopus, a test pattern. The raw data began to stream in, passing through the newly installed software filters. On the main screen, an image began to form. At first it was distorted, a smear of light warped by the residual electronic chaos. The new software learning in real time began to adapt, refining its parameters, identifying and excising the lingering spectral ghosts of 3I, Atlas, and then, slowly, miraculously, the image coalesced. It resolved into a sharp, perfect point of brilliant white light against a velvet black Canopus, clean, stable, real. A ragged cheer erupted in the control room, an explosion of relief that echoed in connected labs across the world. One eye was open. This small victory became the blueprint. The code for the quantum sieve, now refined and battle-tested, was beamed to La Palma to Hawaii, to the control center for the James Webb Space Telescope. Each reboot was its own epic saga of hope and fear. At Keck, watching the twin telescopes slowly recalibrate their adaptive optics in unison felt like witnessing a fallen god learning to stand again. In space, a million miles from any human hand, the reboot of the Webb was the most nail-biting of all. A stream of commands, painstakingly vetted and encrypted, was uploaded across the vastness of space. For 22 agonizing minutes, the team at the Space Telescope Science Institute in Baltimore could do nothing but wait for the response to travel back to Earth. When the telemetry finally arrived, confirming that Webb's instruments were online and protected by the new software, the relief was so profound it was silent. Humanity was no longer blind. We were looking at the universe again, but through new, wiser, and far more cautious eyes. Now, the second phase of the investigation began, a hunt for clues conducted in the digital wreckage. Before the global shutdown, a few of the observatories had managed to capture fragments of data, terabytes of information, most of it corrupted into meaningless noise by the object's overwhelming interference. It was a digital crime scene and the evidence was shattered. But within that chaos, a few precious, uncorrupted packets of information survived, preserved in isolated memory buffers like insects in amber. These digital ghosts became the most valuable artifacts in human history. A new consortium of data scientists, cryptographers, and astrophysicists was formed, their sole mission to piece together these broken shards of light. The first revelation came from the remnants of a photometric reading captured by the Vera C. Rubin Observatory's survey camera just moments before its catastrophic failure. They managed to reconstruct a mere 3 seconds of the object's light curve, its pattern of brightness over time. A normal comet's light curve is smooth, a gentle arc as it reflects sunlight. This was not a gentle arc. The light from 3I, Atlas, was pulsing. It wasn't a random flicker. It was a structured metronomic beat of incredible complexity and perfect regularity, a rhythm more precise than any atomic clock ever built on Earth. It was a signal embedded within a signal, a cosmic heartbeat of impossible precision. Astronomers stared at the waveform, their blood running cold. Natural objects do not behave this way. Stars can pulse, but with a slow, ponderous rhythm. This was fast, intricate, mathematical. It looked less like a celestial phenomenon and more like a broadcast. The next clue was even more disturbing. It was salvaged from the European Southern Observatory's X-shooter spectrograph, an instrument designed to split light into its constituent chemical fingerprints. The data was a mess, a spectral hash of unimaginable energy levels. But after weeks of applying advanced filtering algorithms, they isolated a single clear snapshot of the object's composition, and it made no sense. It contained the expected signatures of water ice and silicates, the classic cometary camouflage. But interwoven with these were spectral lines for elements that had no business being there. There were isotopes of tungsten and osmium so heavy they could only be forged in the heart of a neutron star collision, an event of unimaginable violence. Stranger still were emission lines that corresponded to no known element on the entire periodic table, patterns of light that hinted at a form of matter with atomic structures that should be physically unstable, that should collapse in a nanosecond. It was as if we were looking at the spectral fingerprint of matter from a universe with different laws of physics. Then came the final, most terrifying piece of the puzzle. It was found not in an optical or radio telescope, but in the gravitational wave observatories LIGO and Virgo. They had been designed to detect the colossal space-time ripples from merging black holes and neutron stars. 3I, Atlas, was by comparison gravitationally insignificant. It should have been completely invisible to them. Yet in the moments of its closest approach, both detectors had registered a signal buried deep beneath the noise threshold. It wasn't the slow, powerful swell of a gravitational wave. It was a sharp, localized, incredibly high-frequency gravitational distortion. A team at Caltech running simulations could only replicate the effect with one theoretical model: a microscopic primordial black hole, no larger than a single atom, but with the mass of a mountain. But even that didn't fully fit. The distortion was too controlled, too focused. It wasn't a passive gravitational field. It was being actively projected like a focused beam. An engineer described it in a hushed late-night call as a gravitational scalpel cutting its way through space-time. The fragments were on the table. A precise pulsing light source. A physical body made of impossible, perhaps artificial elements. A focused, projected gravitational field. The implications were staggering, branching into theories that felt more like fever dreams than science. One faction of scientists argued that we had witnessed the passage of a spallation fragment, a piece of an alien star from another galaxy, blasted off in some celestial cataclysm and sent careening across the intergalactic void. Such an object, born from a star with a completely different metallicity and governed by a subtly different set of physical constants, could perhaps explain the bizarre spectral lines and the exotic matter. It would be a true alien in the most fundamental sense of the word. Another group pointing to the gravitational signature revived the theory of primordial black holes. They proposed that 3I, Atlas, was not a comet at all, but one of these ancient relics from the dawn of time, cloaked in a shroud of ice and dust it had collected over billions of years. The intense energy emissions, they argued, were not reflected sunlight, but a unique form of Hawking radiation modified by its interaction with the surrounding matter. This would make it one of the oldest and most exotic objects ever encountered. Its passage would have been a once-in-a-civilization chance to study the very birth of the cosmos. But a third theory, the most fantastic and the most chilling, began to take hold. It was the one that few dared to speak aloud in official meetings, but that dominated the hushed, exhausted conversations in the late hours of the night. The pulsing light was too regular for nature. The exotic elements seemed too deliberately arranged. The gravitational beam was too precise for a passive object. Taken together, these clues painted a deeply unsettling portrait. They were not the hallmarks of a natural phenomenon, however exotic. They were the hallmarks of technology. The conclusion was inescapable, however terrifying. 3I, Atlas, may not have been a comet, or a star fragment, or a black hole. It may have been a probe, an artifact of a civilization so advanced that its very presence overloaded our senses. The blackout wasn't an attack perhaps, but the indifferent consequence of its passing. Its propulsion system, its sensor arrays, its simple existence radiated energies so far beyond our comprehension that our most advanced instruments simply burned out in its presence like a candle held before a celestial blowtorch. We had brought our observatories back from the brink. We had armored them against the unknown. We could see the stars again, but we were no longer looking at the same universe. Before we looked out into the great silent dark and felt a sense of wonder and loneliness. Now we looked into the same darkness, but we knew it was not silent, and we knew with a certainty that would forever change our species that we were not alone. And the next time one of these phantoms drifted through our cosmic neighborhood, we would have to be ready. And so, when the frantic storm of discovery finally subsided, a new and profound quiet descended upon the world. It was not the serene, expectant silence that astronomers cherish, the quiet that precedes a revelation from the distant past. This was a different kind of stillness, the ringing in the ears that follows a cataclysm, a silence filled not with emptiness but with the deafening echo of our own vulnerability. The incident, what we now simply call the Atlas event, had ended. Yet for humanity, a new and uncertain chapter had just begun, fundamentally and forever altering our relationship with the vast dark ocean we had so confidently begun to map. It was more than a scientific anomaly. It became a global cosmic wake-up call, a single terrifying moment that shattered our comfortable assumptions about our place in the universe. We had spent centuries looking up, believing we were merely observers cataloguing a predictable if immense cosmic clockwork. 3I Atlas taught us with brutal efficiency that we were not just watching the show, we were on the stage, and the script was being written by forces beyond our comprehension. The psychological impact on the astronomical community was immediate and deep. These were people who had dedicated their lives to the patient gathering of light, to the painstaking analysis of signals that had traveled for eons. Their instruments were not just tools, they were extensions of human consciousness, our collective eyes and ears reaching out to the furthest shores of space-time. To have those 5 vital organs of perception blinded simultaneously by a mechanism that initially defied physics was a violation. It felt to many like an act of celestial aggression, even if it was born of sheer indifference. The initial shock gave way to a sobering realization: our most advanced billion-dollar observatories, our proudest achievements in engineering and science, had been rendered inert by a passing phantom, a gravitational ghost that had breezed through our cosmic neighborhood without so much as slowing down. The planet's defenses all pointed outward to detect asteroids and comets. Predictable chunks of rock and ice were utterly useless against something so fundamentally alien. We had built a fence to keep out wolves, only to discover that the forest was filled with apparitions that could walk through walls. This newfound sense of fragility precipitated a revolution, galvanizing governments and scientific bodies into an unprecedented era of cooperation. The first and most tangible legacy of 3I, Atlas, was the creation of the Planetary Aegis Initiative, a name chosen with deliberate mythological weight. This was not another telescope network. It was conceived from the ground up as a planetary defense shield, a multi-layered sensory web designed to detect not just what we knew, but what we couldn't yet imagine. Its core mandate was to ensure that humanity would never again be caught so completely unaware. The initiative's flagship program, codenamed Project Cassandra, involved launching a constellation of deep space probes. These were not sent to explore planets, but to act as a celestial tripwire. Stationed far beyond the orbit of Mars at strategic Lagrange points, they form a vast perimeter. Their sensors are a symphony of the exotic, designed to hunt for the very signatures that made Atlas so unique: subtle space-time distortions, anomalous neutrino fluxes, and bursts of particles that have no place in our standard model of physics. They listen for the whispers, not the shouts of the cosmos. Beneath this orbital shield came the ground-based component, the Global Synoptic Array, or GSA. It repurposed the hard-won lessons from the event, integrating the world's surviving radio telescopes, optical observatories, and even gravitational wave detectors into a single, artificially intelligent brain. This AI, named Genesis for the two-faced god of beginnings and endings, does not wait for human analysis. It sifts through petabytes of data every second, learning the normal rhythmic pulse of the observable universe. Its sole purpose is to find the arrhythmia, the single beat that is out of place, the one anomalous signal that could herald the approach of another object like 3I, Atlas. Before the event, such global integration was a bureaucratic nightmare tangled in national interests and academic rivalries. Afterward, it became a survival imperative. The data streams from every major observatory, once proprietary, now flow into the GSA's neural network, a torrent of information creating a real-time, high-fidelity portrait of our cosmic environment. We had finally understood that in the face of such profound mystery, our only hope was to see with one collective planetary eye. This new infrastructure, however, was merely the hardware. The true shift was in the software of our scientific thinking. The Atlas event ignited a renaissance in theoretical physics and observational astronomy, forcing a generation of scientists to tear up their assumptions and confront the unknown with a renewed sense of humility and vigor. Entirely new fields of study were born from the ashes of those 5 disabled observatories. Exotic matter tomography emerged as a discipline dedicated to remotely analyzing the composition of interstellar objects using the subtle gravitational lensing and particle scattering effects they produce. We were no longer content to just measure their trajectory. We needed to know what they were times made of asterisk. Laboratories from Pasadena to Munich are now racing to replicate the unique energy signature of 3I, Atlas, a bizarre form of coherent energy that seemed to specifically target the complex electronics of our most sensitive detectors. Was it a side effect of a novel propulsion system, a defensive mechanism, or a natural phenomenon generated by a state of matter so dense and energetic it exists nowhere in our solar system? These questions are now the driving force behind billions of dollars in research funding and the focus of the FLA's brightest minds on the planet. Furthermore, the incident shattered the quiet confidence of the search for extraterrestrial intelligence. For decades, SETI programs had scanned the skies for narrowband radio signals, the telltale sign of a deliberate, ordered transmission. It was a search based on the assumption that another intelligence would want to talk to announce itself with a cosmic hello. 3I, Atlas, offered a chilling alternative. What if the first evidence of advanced technology wasn't a message, but the silent, indifferent wake of its passage? What if the most powerful civilizations in the galaxy have no interest in communication, their technology operating on principles that affect us as incidentally as a container ship's wake might swamp a fisherman's tiny canoe? This has given rise to a new search paradigm, sometimes called artifact SETI, or interstellar archaeology. Instead of listening for greetings, scientists are now actively hunting for the subtle, anomalous footprints of technology, the gravitational echoes, the strange thermal gradients, the inexplicable particle decays that might betray the presence of something engineered, something artificial passing through the void. It's a far more difficult and ambiguous search, but one that now seems infinitely more realistic. And yet, for all the new programs, for all the accelerated research and frantic innovation, the central character of our story, 3I, Atlas itself, remains an enigma, a celestial ghost that grows more mysterious with each new simulation. We have its trajectory, a precise cold line of mathematics charting its path through our system and back out into the interstellar darkness. We have the data from its fleeting encounter, the spectral analysis of its coma, and the terrifying signature of the energy pulse that crippled our observatories. But we do not have the object itself. It is gone, likely forever, having faded back into the limitless expanse between the stars, leaving us with a collection of profound and unsettling questions that may never be answered. Where did it come from? The trajectory points vaguely in the direction of the Cygnus Rift, but its path is not a simple ballistic arc. There are subtle deviations, minute course corrections that our best models cannot explain through natural gravitational interactions alone. It moved as if it had agency, a faint but persistent whisper of intention in its celestial mechanics. What was its purpose? This is the question that haunts the dreams of those who were there, the scientists who watched their life's work go dark in an instant. Was the disabling of our observatories a deliberate act? A warning shot across our bow from an unseen intelligence? A demonstration of technological superiority? Or was it, as many now theorize, something far more humbling? Perhaps we were simply irrelevant. The energy pulse could have been a byproduct of its internal systems, an exhaust plume from a physics we do not understand, an effect as incidental to its journey as the static from a car's engine is to an ant on the pavement. This latter possibility is in many ways the more terrifying. It suggests a universe filled with powers so immense, so far beyond our own nascent capabilities, that our very existence is a footnote, a momentary bit of cosmic interference. We want to believe we were noticed even as an adversary. The thought that we were not even a curiosity, that our most powerful tools were swatted aside by accident, is a profound blow to our collective ego. And perhaps the most enduring scientific question is one of composition. What times was times 3, I, Atlas? Its gravitational influence was far greater than its visual size would suggest, hinting at a density that borders on the physically impossible for conventional matter. It seemed to be a singularity without a black hole, a gravitational anchor dragging a wisp of gas and dust behind it. Theories range from a fragment of a neutron star somehow stabilized and set on an interstellar path to a piece of engineered magmatter, a hypothetical state of matter where atoms are collapsed and ordered by intense magnetic fields. Some even whisper of more exotic possibilities of a vessel navigating through a higher dimension, its passage through our three-dimensional space causing the strange effects we observed. We have no way of knowing. Without a sample, without another visitation, 3I, Atlas, remains a scientific spectre, a data point that sits impossibly far from the trend line of our understanding, forcing us to admit that our catalogue of the cosmic zoo is missing its most fascinating creatures. It was a messenger that delivered a locked box, and we have been left to guess at its contents. Ultimately, the legacy of 3I, Atlas, is not one of fear but of perspective. It was the universe's most powerful lesson in humility. For centuries, our journey into the cosmos has been one of relentless expansion both in knowledge and in ambition. From Galileo's first spyglass to the great observatories perched on mountains and floating in space, our story has been one of peeling back the layers of creation, of solving one mystery only to find another, more complex puzzle waiting beneath. We became confident, perhaps even arrogant in our methods. We believed that with enough time, enough funding, enough ingenuity, every secret of the universe would eventually yield to our inquiry. We saw ourselves as the inheritors of the cosmos, destined to understand and perhaps one day master it. The Atlas event did not destroy that ambition, but it tempered it with a vital and long overdue dose of awe. It reminded us that we are newcomers in a very old and very strange place, and that our knowledge is but a tiny island in an infinite ocean of the unknown. It forced us to confront our own technological infancy. The very tools that we saw as the pinnacle of our achievement, the instruments that could witness the birth of galaxies, were shown to be fragile curiosities in the face of a true cosmic power. This realization has sparked a new kind of space race, one that is not about planting flags or national pride, but about survival and understanding. It is a race to build more resilient systems, to develop new physical theories, to expand our senses beyond the comfortable confines of the electromagnetic spectrum. It is a quiet, determined global effort to grow up to mature as a technological species, to prepare ourselves for a universe that has proven to be more active, more complex, and potentially more dangerous than we ever imagined. The empty sky is no longer empty. It is now filled with possibility, with the awareness that other travelers are on the road and their destinations are unknown. So we continue to look up, but our gaze has changed. It is no longer just the patient, curious stare of the scientist or the romantic wonder of the poet. There is a new intensity in our watch, a new vigilance. We are listening more carefully, looking for subtler signs and preparing for surprises. The darkness between the stars is not a void, it is a frontier. And 3I, Atlas, was our first shocking contact with its true untamed nature. It left no crater, fired no weapon, and spoke no word, but its message was delivered with unmistakable clarity, etched into the sudden, coordinated silence of our greatest eyes on the universe. A message that simply confirmed what we had always suspected deep in our hearts: we are part of something immeasurably vast and endlessly surprising. And our greatest journey, the quest to understand our place within it, has only just begun. The universe is waiting, and we must be ready.